Hello and welcome to Diana's Makerspace. Today, for the weekend, I did a little a weekend project making a Z80 system 2, but this one has a special feature that it actually includes an SPI programmer on that you can actually program it using the SPI bus, and also it has a Z80 processor that allows you to actually test the Z80 with a 4 megabytes clock chip, and it is all self-contained. Let me show you. Now, as we look at the system, you can start to see basically that there's quite a few things that were done. Let me just get something to point with. Um, First thing is basically this is a 595 165 for reading the data port. This is the SPI control module, but you'll notice that basically it has two 8-pin headers on here, so you can actually control module remotely. And the same thing here with the data port, you can control that remotely. And an expansion bus, so basically you can add other peripherals to it. And this is a simple display test using a 273 latch for port control, and also the processor. But the most important thing is if we zoom in a little bit, you'll see a transistor here. And what happens is transistor is being used as an inverter. I could use a 7400 or a 7404, but you notice to keep everything on, I'm running out of space, so a transistor works perfectly. So basically what you do is basically you connect the clock signal to basically the collector pin, and then you connect the IO request to the base pin, and then the emitter basically to ground. So what happens when the IO request is high, basically this clock is low, and this data latch will not be enabled. But when the IO request is low, this latch becomes high, and on a low to high transition, this data latch is enabled. And you can see there are 4 lights here: output 1, output 2, output 3, output 4. So you can do a test, and a self-contained oscillator, which is controlled from the expansion bus, as well as the power supply. This uses an 8255 chip that's connected to a W29C chip, and hooked on with the zip socket. So basically, you can take the chip in and out. And as I do this, I watch YouTube videos. I was doing this as I was watching a YouTube video where one person was repairing a clone of an Apple II Plus Adrian's Digital Workshop. So sometimes I do this as a way. And this project so far took me about an hour to do yesterday, and about an hour to do today. It's about a 2-hour project. And I do recommend using DuPont wire. You can use jumper wire for some things, which I'm going to do. But for some of this, like where you have a close connection where you only have one row of pins available here, or 2 rows of pin available here, and one row of pins available there, I recommend using DuPont wires, because basically sometimes jumper wires will break. And also to get 8-pin headers, you can also get 4 pins. And next order, I'm going to get 16-pin headers and 10-pin headers. Now you notice with the headers, let me just show you something with the headers though. When you look at the headers, sometimes on the breadboard, the headers don't completely align with each other. So what you have to do is you sort of have to tile them, like I did. So you tile them. So this is actually going to be D0 to D8. This is actually going to be A0 to A8, and this is going to be A9 to A13. Well, let me know what you think. And the best way to reach me is on YouTube, X, and Pinterest. And just to show you one other thing, today is a casual Sunday, so the Barbies are all dressed and Mike are dressed in the casual clothes. I have added a new sofa to this, and and you can see I'm sort of trying to update the craft space and the workspace. And this is one a project I'm working on. You can see also I added some computers to do graphics as well as podcasting. And this is my little casual table where I have different things here: coffee, soda, and that though. Oh, another thing I wanted to show. Let me just pause this again. Whenever you do work like this, it's always good to have a schematic of what you're working at, the components. I use an app called a component app that's available on Play Store. And some people say, well, you could just use it, put it on your screen, but I still prefer printing it out on paper because for me it's very easy to remember stuff when it's printed on paper. Because some places try to limit you on printing on paper, but certain things you should print out on paper because it gets very tedious flicking between screens, and also with your eyes. So if you're older, flicking between screens does bother your eyes. So this is the one for the 256 CMOS memory that's being used, and I'm going to make that into a bank switch memory. Now this is for the D flip-flop 74273. A newer version is 74573. And let's see, whoops, just a minute. And this is the one for the 8255. And you can see basically trying to flip between screens and do all this is sometimes easier just to put two pieces of paper together to do this. And that's why, in a way, it's good to get the schematics of what you're working with when you do this type of thing. Another thing I wanted to show as well is this is a net list on how things are hooked up. You can see basically W29C A255 595 165, W29C 595 595 165 and 595 2. So that's important to be able to do this and make a net list with this. And in conclusion, this is what the system looks basically almost fully assembled. I'm going to test it with the blink program where basically it's going to do a blink lights 1, 2, 3, 4, 1, 2, 1, 2, 3, 4 off, 1, 2, 3, 4 off, 1, 2, 3, 4 off. I'm going to light a Z80 program to do that, and then flash the CMOS and show you that in a few other videos. Well, let me know what you think, and the best way is to reach me, as I mentioned before. And this concludes Diana's Makerspace for June 1st, 2025.